Page 316, number 5, sketch a graph of the function y equals 1/2 times the tangent of x. Well, before we graph this, let's just talk about what this function would look like. Y equals the tangent of x. Well, my tangent curve will have an asymptote right here at negative pi over 2, and another asymptote right here at pi over 2. The tangent curve starts down here, goes through the origin, curves up this way, continues on forever, but approaches those asymptotes and never touches them. Now this curve repeats itself over and over. Now the question here is, what does this 1/2 do to the graph of the tangent function? Well, what it does is it makes the tangent curve half as tall. Well, you might think to yourself, if this continues forever, how can it possibly be half as tall? Let's just think about a point. I'll pick a point right here on this graph. If this point were half as far away from the x-axis, it would be right here instead. So we're going to see the same kind of curve, except it's going to actually just kind of be squished down a little bit, and that's how we can make this curve half as tall. Now this curve is going to repeat itself over and over, so I can draw a similar one here. There will be an asymptote every pi unit, so we've got an asymptote at negative pi over 2, at pi over 2. We're going to have our next asymptote at 3 pi over 2, then at 5 pi over 2, etc., etc. Now we can verify this graph by taking a look at the same graph on our calculator. We'll press y equals, and we'll start with, I'll put it in parentheses, 1/2, close those parentheses, and type times the tangent of x. And if I graph that, I see those curves approaching those asymptotes. It does go through the origin, but our graph looks very similar to the graph we sketched by hand.